we will discuss some more problems on fluid pressure and also how to measure fluid pressure using manometers in this class. So here this is the problem given. It's a closed tank. This is a closed tank which has got two liquids. So at the bottom it has water up to a height of 1 meter, and above water you have an oil which is slightly lighter than water with specific gravity 0.8 to a height of 0.75 meter, and he has given the pressure at this point at the top of this oil layer. There is a dial gauge there. You can pressure gauge there. The pressure at that point A at the top of this oil surface, it is given as 50 millimeter of mercury, but it is vacuum. Vacuum means it is negative pressure, suction pressure. So here the question is, what is the pressure at the bottom of the tank? That is at the point C. If you take a point at the bottom C, so we have to determine the pressure at the bottom of the tank, that is at the point C. That is the question here. So you should be very careful in such types of problems because there are three different, there are two liquids here and the pressure here is in terms of mercury. So there are three different liquids in this problem. So be careful when you are analyzing the such types of problem with different liquids. Better you convert them to in terms of water. So that is better. Now here, of course, by hydrostatic principle, hydrostatic pressure law, so what we can do here is, pressure at A is known here, so PA is the pressure here. If you want pressure at B, that is the thing called pressure at A plus pressure of this oil which is present from A to B. Next, if you want pressure at C, it is the thing called pressure at B plus whatever pressure exerted by this water between B and C. So like that is the concept of hydrostatic pressure law, and we know that pressure is equal to gamma into H. So this equation, you know, this is the hydrostatic pressure law. Using this concept, you can find out the pressure at any level. The only thing is you should be knowing the specific weight of that particular liquid and the depth of that liquid. So above that particular point, then only you can find out the pressure at the required point or the required level. Now we will do this problem in three stages. So first I will take pressure at A, then I will calculate pressure at B, then I will calculate pressure at C. So first step, pressure at A, it is given here in this problem. It is minus 50 millimeters of mercury because this vacuum. Please note that since it is given as vacuum, we have to take this pressure as negative. So vacuum pressure is negative gauge pressure. All these expressions what we are writing here for pressure, they are all gauge pressure expressions. So this what I will do here, I will convert this into in terms of water. So because water is the common fluid or reference fluid we can use for pressure calculation. So if I want to convert this into meters of water, so mercury minus 50 mm. So that is my 50 mm should be converted to meters. That is divided by 1000 means minus 0.05 meters of mercury. If you want to convert that in terms of water, multiply that by the specific gravity of mercury. So this I have explained in the earlier lecture also. So if you want to convert this pressure of mercury to pressure of water, you have to multiply by 13.6. So if you do that, you are getting minus 0.68 meters of water. Now what I will do here is, this is in meters of water, that is in terms of pressure head. This I will convert into Newton per meter square. So using that gamma into H formula. So now this is H, 6.68, and gamma of water is 9810. So it becomes 6670.8 Newton per meter square. So the pressure at A is 50 mm of mercury vacuum given. It is the same as minus 6670.8 Newton per meter square of water. So I have converted pressure in terms of mercury to in terms of water, that too in Newton per meter square or Pascal. Now next step I am going to calculate the pressure at B, PB. This PB is nothing but I already told this PA, whatever pressure is there at this level, plus pressure due to this oil. Plus we have to add because pressure at B is more than pressure at A. So PA plus pressure at B will be whatever pressure of oil is, whatever gamma is there, multiplied by gamma of oil, multiplied by H of oil. So this H of oil is this value. What is the height of that oil liquid is there. So that H naught I have to take. So gamma naught into H naught is the pressure due to this oil at point B. So now what we have to do here is PA already you know in terms of Newton per millimeter square minus 6670.8 that you write, plus gamma of oil you need to calculate because gamma of oil is not given. Instead of that he has given specific gravity of oil. Now multiply the specific gravity of oil by specific weight of water to get the specific weight of oil. So it becomes 0.8 into 9810, 7848. So gamma of oil is 7848 Newton per meter cube. That multiplied by this depth of oil which is 0.75 meters. So this is in meters, this is in Newton per meter cube, this is in Newton per meter square. So this becomes Newton per meter square. If you simplify, you are going to get this is minus, this is plus, minus 784.8 Newton per meter square. And that means this is also vacuum. So pressure at B is also negative, vacuum pressure. Pressure at A is also vacuum. Now after that we have to find the pressure at C, PC. PC as I already told, it is nothing but pressure at B plus pressure due to this water which is present from B to C. So height I will take it as HW. HW is 1 meter here. So PC is equal to PB plus gamma W into HW. So P is equal to gamma H, that formula we are using. Since water is there, we have to take gamma W into HW. So it is minus 784.8 plus gamma W is 9810 into HW is depth of water which is 1 meter. If you simplify this, you will get 9025.2 Newton per meter square. Of course, here the pressure becomes positive. So at C, you have a positive gauge pressure, whereas at A and B, you have negative gauge pressures or the vacuum pressure. So this is how we have to do the problem. So what I have done here is, mercury I have converted in terms of water, oil I have converted in terms of water, and third one is water only. So this is how. So be very careful when you are doing problems on fluid pressures which is having more than one liquid. Convert all pressure values in terms of water and in terms of same unit, either in meters or Newton per meter square. So this concept you have to keep it in mind. Now next is manometers. So you know that the barometer is used to measure the atmospheric pressure at a place, whereas manometers are used to measure the pressure at a point in a fluid flow or in a static fluid, or sometimes you may need to find the pressure difference between 2 points in a pipe flow for calculating discharge and all. So in that case, we are going to use differential manometers. So there are two types of manometers. One is simple manometers. They are used to measure the pressure at a point in a fluid flow or in a static mass of fluid, whereas differential manometers are used to measure the pressure difference between 2 points. Only in a pipe flow, only if you have pressure difference between 2 points, then only flow will take place. So flow in pipes is due to only pressure difference, whereas flow in channels is due to gravity or due to atmospheric pressure. Now here, this is a simple example of simple manometer. So in the case of a simple manometer, suppose this is a pipe where through which some liquid is flowing. Let us take that specific weight of that liquid as gamma. A glass tube is inserted at some point where the pressure is required. So suppose if I need the pressure at the point A glass tube is introduced here. This tube is also called as piezometer. It can also be called as a piezometer. So once you insert a tube there at that point, the liquid level will rise here and stand at some point. So that distance, vertical distance from this liquid level and the the center line of the pipe, that I have taken as H1. If gamma is the specific weight of the liquid which is flowing through the pipe, when it is multiplied by this H1, so this H1 appears as the pressure head. So gamma into H1 gives the value of the pressure at A. Similarly, when you take another point B, if you insert a tube there, prismatic tube there, that behaves as a simple manometer, and if the depth of water, depth of the liquid column is H2 at that point, then same liquid is flowing here. Gamma into H2 gives the value of the pressure at the point B. So this is how pressure at a point can be measured using a simple manometer. Of course, piezometer is a simple example of simple manometer. Similarly, you have one more called U-tube manometer and single column manometer, also examples for simple manometers. Now the second example is for differential manometer. As I already told, if you want to measure the pressure difference between 2 points, then a differential manometer is used. In that you have different types: inverted U-tube differential manometer, U-tube differential manometer, micro manometer, like that. So different types are there in differential manometer. Also, here I have taken a U-tube differential manometer. U-tube differential manometer. So which is used to measure the pressure difference between 2 points in a flow. So this is a pipe. Once again, this is a pipe through which some liquid is flowing. So here I have taken a specific gravity of that liquid. Instead of specific weight, I have taken specific gravity of the liquid which is flowing in the pipe as S1. And the manometric liquid is that usually mercury is used as the manometric liquid. So I will take specific gravity of mercury as SHG. Usually it is 13.6. If they don't give any value, you have to take 13.6 for SHG. Now what happens in this case? In the case of a differential manometer, so always flow occurs from high pressure region to low pressure region. So I have taken the direction of flow here from A to B. That means it means to say that pressure at A is greater than pressure at B. Then only the flow takes place from A to B. Since the pressure at A is more than pressure at B, whatever liquid is flowing through this pipe, it exerts more pressure at this point and less pressure at this point. Okay, same liquid is flowing. So that is why I have shown the mercury level below here and above here. So this difference in the mercury levels is the deflection in mercury level. I have denoted it by H, small h. This you can read out using scale. So all these H1, H2, H, all these things you can measure using the scale. So now once you know the reading, mercury level reading, you can always find out the pressure difference between these 2 points. So PA minus PB. So because PA is greater than PB, you can always find out the pressure difference PA minus PB by writing one important equation called gauge equation. So this is very important. So this step you have to understand clearly. In any manometer problem, if you know how to write the gauge equation, then you can solve the problem. So gauge equation in terms of meters of water. Once again, why I am taking in terms of water is many fluids may be used, many types of liquids may be used in manometers. So better you convert all the pressure values in terms of water, that too in meters of water. Now all of you be careful here how I am going to write the gauge equation. I will explain. Once you know that, then you can solve any problem on manometer. Now what I will do here is, this point is A, this is B, which is there in the pipe, and this point I will take as C. So where the mercury level stands in this limb, this is called as limb. This is left limb, this is right limb, and this point I will take it as D. Now there are 4 points A, C, D, B. So flow occurs like this. Now what you have to do here is, you have to start writing the pressures at starting from point A, you have to move towards point B by writing the pressure expressions. Now the pressure at A in terms of water is PA by gamma W. Please note that I am writing in terms of pressure head. So PA by gamma means, P by gamma means it is H only. So that is why I have written here in terms of meters of water. So the first term is PA by gamma W. PA by gamma W pressure head at A in terms of water. Then come to the next point, which is C here. Please note that C is below A. C is below A. If the point is below the earlier point, pressure is more there. So because it exerts more pressure. So always pressure is more at the bottommost point. So I have to take plus then. I have to take plus. So plus, how I have write here is distance from this point to this point, that is x1, into whatever liquid is there between that A and B, A and C, specific gravity of that is S1 here. So what I have plus, because C is below A, into plus x1 is the distance between A and C, into S1 is the specificity of the liquid which is contained between A and C. Next point is D. From C you have to move towards D. From C to D you have mercury here. That is the manometric fluid from C to D. But please observe that here this D is above C. Since D is above C, pressure at D will be less than pressure at C. Be careful here. So since the pressure at D is less than pressure at C, we have to take minus sign. Minus sign. So now it continues. So once again what you have to do? We have to write the difference in the levels, that is H here, into specific gravity of the fluid which is contained between C and D, that is SHG. Next point is B. B is above D. Since B is above D, once again pressure is less. Less means I have to take minus sign. So when you are moving downwards, expression is plus, sign is plus. When you are moving upwards from the previous point, the sign is negative. So minus, here the distance between these two I will take it as x2 into, once again this liquid is there in this region between D and B, that is S1. This is, now we have come up to this stage. Up to this stage we have come. So we have started here, we have ended here. So this expression whatever is there we have got, that is nothing but your PV by gamma W, that is the pressure at B in terms of water. So this is how you have to write the gauge equation. Very, very important, very easy. So only in terms of water we have to write. So because many liquids can be used, whatever the liquid they use, only thing is you should know the specific gravity of that liquid which is flowing in the pipe or which is there in the manometer. Only if you don't know the specific gravity, if they give specific weight or mass density, you should find the specific gravity value and then we have to use that value in the gauge equation. Now once you write the gauge equation, now you can rearrange these terms. PA by gamma W minus PB by gamma W is equal to, so all these terms become negative when they go to right side, minus x1 s1 plus h into shg plus x2 into s1. Then this divided by gamma W also term you can bring to RHS, it becomes into. So this is the expression. So all these values you will be knowing. You will be knowing all these values, x1, s1, x2, then shg, h, all these values you will be knowing. You can find the pressure difference in terms of course, Newton per meter square. This P is expressed in terms of Newton per meter square. H, x1, x2, they are all expressed in terms of meters. Please note that if the value you know in terms of centimeters or millimeters, that should be converted to meters, and of course gamma W will be in terms of Newton per meter cube. That is 9810 Newton per meter cube. It is constant. You can directly write that value. So this is how starting from the first point up to the end point, last point, we can write the gauge equation. If any point lies below the previous point, its pressure, we have to take plus sign. If the point lies above the previous point, we have to write minus. So that is very important. This is the pressure at A. Pressure at B will be this plus this. This is pressure at B. If you take three terms, pressure at A is PA by gamma W. Pressure at C will be these two. Pressure at D will be this plus this minus this. Then for all the four terms if you take, that gives the pressure at B. That is why in the RHS I have taken it as pressure at B. Suppose if the RHS if the last point is exposed to atmosphere, we have to take it as 0, because atmospheric pressure is taken as the reference. When you are writing the equation in terms of gauge pressure, atmospheric pressure is taken as reference. Reference means 0, so it should be taken as 0. So once you know all these values here, this is of course 9810 Newton per meter cube. This is constant gamma W value. Once you know all these values, PA minus PB can be found out. Sometimes in any problem, they may give the difference in pressure. They may give PA and PB. They may give, or they may give the difference, that is PA minus PB. They may give. They may ask you to find out this H. What is the deflection in the mercury level? So H may be the unknown. So like this different unknowns they may be asking, but it all depends on the data. But for finding any unknown, first we have to write the gauge equation, and then you have to solve. Of course, in the next class I am going to solve some problems on this. One problem let us take here. This type of this is a U-tube manometer. U-tube manometer, that is a simple manometer. It's an example of simple manometer. That means we are measuring the pressure at only one point. So in this problem, so there is a pipe here. Cross section of the pipe is given. So some oil is flowing through this pipe. Oil is flowing. I have taken the cross section. Oil is flowing like this. The specific gravity of the oil is 0.8. It is lighter than water. For water it is 1.8. And that point is connected. That pipe is connected to a U-tube manometer to measure the pressure in the pipe. So pressure in the pipe is something called PA. PA we have to find out. So when you connect, it is connected to a U-tube manometer, so oil is there from here to here. You have mercury here in the manometer. Usually mercury is used because its vapor pressure is very high and its specific gravity value is very high. It won't mix with other fluids. So all these properties make mercury to be used in manometers. It is immiscible. It won't mix with other liquids because its specific gravity value is very high. And also you can measure large pressure differences by noting down a small deflection in the mercury levels. Here that mercury levels he has given. So from the center of the pipe to this mercury level, it is 60 mm, that is 0.06 meters. And at the other limb, so these two are called as the limbs, left limb, right limb. Other limb, it is open to atmosphere. So please note that the pressure at sea is there, pressure at sea is atmospheric pressure, which we have to take it as 0, very important. It is open to atmosphere here. It is not closed. Whereas here, it is within the pipe. When the point is within the pipe, then the pressure is not atmospheric. Here it is open to atmosphere. Therefore, whatever pressure exerts here, that is nothing but P atmosphere, which we are going to take it as 0 because we are writing in terms of gauge pressure. Now, so these are the level differences in the mercury he has given. The question is determine the pressure in the pipe. So pressure in the pipe means it is PA. PA value we have to find out. So by writing the gauge equation, we will find that the solution runs like this. Gauge equation in terms of meters of water. So I have explained here. Similar procedure we are going to follow here. So pressure at A becomes PA by gamma W. First term is always PA by gamma W. Next point I will take here. So wherever there is change in liquid, that point you name it. So now there is a change here from oil to mercury. So this point I will take it as C, and the last point I will take it as B. Last point I will take it as C. Now, according to this concept, B is below A. When the point is below the previous point, pressure is more. That means you have to use plus sign. Plus. What is the distance? Distance between these 2 points in meters we have to write. So please be careful. If they give in centimeters or millimeters, convert them to meter. So 0.06 is the distance meter. Then you have to take the specific gravity multiplied by the specific gravity of the liquid which is contained between A and B, that is oil, that is 0.8. So this is your S1 value. Okay. So this is in meters. This is S1 value. Next, from B you have to go to C. C is above B. Since C is above B, its pressure at C will be less than pressure at C will be less than pressure at B. So we have to take minus sign. So because we are moving upwards, we have to take minus sign. So here also distance from B to C we have to take now. Distance from B to C is this 90 mm is 0.09 meter. I have to add these two now. When you add 0.06 and 0.09, you are getting 0.15. So this is the distance between B and C. Okay. Here we have to take the distance between A and B. Here B and C. Meters, in meters. Into specific gravity of the liquid which is contained between those 2 points. So between these 2 points, mercury is there. Its specific gravity is 13.6. So into 13.6. This should be equal to, now we have come to the end point C. So this should be equal to Pc by gamma W. I have written here last point. So Pc by gamma W. But Pc here it is 0 because Pc is equal to atmospheric pressure, and that is taken as the reference. This is the gauge equation, gauge pressure equation. Atmospheric pressure is the reference, that is it is taken as 0. Your RHS becomes 0 here. So at the last point, if it is exposed to atmosphere, then pressure value we are going to take it as 0 for in the gauge equation. Now you have to simplify this. So RHS is 0 now. So Pa by gamma W becomes now, if you simplify this, bring these two to RHS, this becomes minus, this becomes plus. If you simplify, you will get 1.992 meters of water. So please note that whatever value you get, that will be in meters of water. Very, very important. Meters of water. Then you can, if you want, you can convert that into Newton per meter square. If you want to convert it into Newton per meter square, Pa will be equal to 1.992 multiplied by gamma W. So this into this. So you have to multiply, you are going to get Pa, which is 19541.52 Newton per meter square or pascals. So this, since it is a very high value, divided by 1000, you will get in kilopascals. So 19.54152 kilopascals. That is the pressure at the point A. So this is the problem where it is asked to find the pressure at a point using a simple manometer, which is in the form of a U-tube manometer. So this is how we have to do the problem. So you have to understand how to write the gauge equation. Very, very important. Starting from first point till the end point. So where they require the pressure difference, till that you have to move. If the point is below the previous point, pressure we have to add the value. If the point is above the previous point, you have to subtract. So plus minus sign we have to use. And another thing is we are writing the gauge equation in terms of meters of water. Finally, whatever answer you are going to get, it will be in terms of meters of water. And then later on, by multiplying that value, whatever you get by the specific weight of water, that is 9010, you will be getting the value in Newton per meter square. Later on, you can convert that into kilopascals also.